and he is with the Kentucky State University. He helps with University of Kentucky Extension as well. He's housed out of Western Kentucky side of the state, and he helps all things. I know we discussed some of it last week. He helps all things with any questions any of the agents have on anything aquatic. So we talk a lot every summer, and I know he and I do. And he's always a wealth of knowledge, and he's always willing to help, and he helps us quite a bit here in Fleming County, and I know our surrounding counties here. So Forrest, we always thank you very much for helping us, and we also thank you for joining us tonight again to share your expertise on algae and aquatic plant control. So Forrest, I'll turn it over to you.
Thank you, April, and thank you to all those that have taken time out of dinner later in your afternoon, evening to join us. Yeah, I'm going to run through a few slides here, and hopefully it won't take too terribly long, and answer some of your questions, and then we'll try to address some questions later on. So this is, as April mentioned, a session on aquatic plant control and algae control in ponds. So we'll go ahead and first, again, this is a little bit of a review from last week, but we need to be really upfront and conscious of what our ponds are being used for, because oftentimes we'll add either an algicide or a herbicide to the water. So we want to make sure that we're not injuring crops we may be irrigating, livestock that we may be watering, and this sort of thing. So we've got to make sure that our plant and algae management program is not interfering, excuse me, with the uses of the body of water at hand. And ponds can be used for all kinds of purposes. Primarily, I'm going to be talking about recreational ponds that are used for fishing and as it said, recreation, swimming, perhaps boating. But there are all kinds of other uses, and on the left-hand side of the screen here, you'll see some of them listed. Some of the things we can do while constructing and siting a pond is really important in terms of management of the pond, and especially for aquatic plant and algae control. Probably the biggest thing we can do when we construct a pond is avoid shallow areas around the edge of the pond. Probably keep it at a minimum of 2.5 feet deep, maybe even 3 feet deep around the edges, and this will help prevent the spread of algae and aquatic plants, which usually get started in the shallow portions of the pond and work their way in towards the center of the pond. So a lot of times you'll see algal growth or plants growing around the perimeter of the pond, around the edges, and then as it gets later and later into the summer, the plant growth starts to move out towards the center of the pond. Some other things, kind of obvious things, almost all of our ponds are watershed ponds. So they receive runoff from the surrounding watershed or land, hill ponds, if you want to call them that. Whatever's going on in the watershed is obviously going to drain into the ponds during a heavy rain situation. So if there's septic or excessive fertilizer from crops, lawns, this sort of thing, manure, this has a potential to wash into the pond. So we want to make sure that particularly in the case of fertilization, that fertilizing soils, that we have proper soil testing done. So we're not wasting money in terms of excess fertilizer, and have the right fertilizer, but we're also wanting to make sure any excess fertilizer doesn't run off into the pond and cause us further algae and plant control problems. So that's really important to drive home, that soil testing and what goes on in the watershed of most of our ponds is really going to influence water quality and what the aesthetics and the plant growth situation is in our watershed ponds. Buffer strips around the edge can help. Grassy strips, 50, 100 feet wide, whatever you can do, depending on how steep the land is. Any kind of grass buffer between, let's say, crops or livestock operations will help filter out nutrients going into the water. And the big one we're really concerned about is phosphorus. Phosphorus is what drives plant and algae growth in fresh water. So we want to especially minimize phosphorus, and to some degree nitrogen as well. Potassium, potash doesn't really play much of a role in aquatic systems, but it's mostly phosphorus, and it's mostly and followed by nitrogen as the important nutrients to stimulate plant growth in fresh water. With saying all this, it's important, if possible, to keep cattle out of the ponds from wading, loafing, swimming, whatever you want to call it, because they are a good source of nutrient going into the pond and can pollute them rather badly and erode and trample the banks. So if you can limit livestock access to the pond, either by fencing it off entirely or keeping a water tank below where they can drink from, I'm told it's better for the livestock, and it's certainly better for the pond environment. So that's another thing to consider is, again, just good management of the body of water you have, and it should last a good long time. One of the things we can do, and we do it out in Western Kentucky and particularly in Eastern Kentucky as well, where we have acidic soils, may not have any limestone formation in our geologies. Liming the soils is much the same as you would lime a field for crop production. Here we want to get that pH up around 7, a very high liming recommendation for ponds, similar to that of alfalfa. This will also help stimulate the kind of plant growth we want, mostly in the form of plankton that will feed the food system of the pond, and not necessarily filamentous algae or an abundance of aquatic plants, which really won't stimulate fish production. We want to make sure that nutrients are available from the pond muds into the pond water, but we want to make sure there's not too much nutrient. And generally speaking, I can do some water testing here. We go into total alkalinity, we test that, and if total alkalinity, which is a measure of buffering capacity of pH, if that registers below 30 milligrams per liter, generally we say it's a good idea to lime the pond if you can do it. And we discussed some of this last week. I just wanted to reiterate again, it's really an important pond management tool, not only for fish growth, but it can also help you with plant and algae control as well. So steps to controlling algae and aquatic vegetation. You'll see throughout this presentation a number of photographs of different types of algae and different types of plants. And those are really useful in a digital age where we've got cell phones that will take good pictures of these types of plants and algae. We can use these to help us identify what the problem plants are. So good pictures, good identification is really key to what we're trying to do here. If we've misidentified the plant and go out and buy the wrong chemical, we've wasted time, we've wasted money, and possibly caused not such a great environmental situation in the pond just by virtue of using the wrong chemical. So again, I've already talked about other pond uses. We want to consider those. What's going on with your pond? Is it just recreational, or is the water being used for even domestic use or livestock use or irrigation, just whatever's going on? And to some extent, we do need to know the water chemistry. And I just mentioned that with regard to liming and testing total alkalinity or the buffering capacity of the water. That is to buffer acids. So when we're identifying types of plants and algal growth, we've come up with these fictitious type of groupings to help us categorize what we're looking at. And over to your left, you'll see cattails sticking out of the water, and we refer to those as emergent vegetation, where obviously the plant is rooted in the bottom of the pond in some wet soils, but a lot of the plant, or at least some of the plant, is sticking above the water surface. And this would include your primroses. It would include a lot of different plants, water lilies, cattails. Then further out into the picture, about center picture, we've got free floating plants. These are the plants such as duckweeds, water fern or mosquito fern, and also water meal. And these are plants, just as I say, float around on the surface. We have filamentous algae, which basically starts on the bottom of the pond. It doesn't have roots, but the growth starts on the bottom of the pond and forms these floating mats of algal mass, and they break off and float around the pond. So to a lot of folks, they would seem like floating plants. On the far right, we have submerged vegetation, which is largely underwater or completely underwater. Examples of this would be coontail and Elodea, some of these other plants that we come across. And last, and certainly not least, we have phytoplankton. These are small-celled unicellular organisms that are so small you really can't see them without a microscope. But they're very important to the food chain. This is what the small fish, the insects and vertebrates that small fish eat live off of this phytoplankton. And of course, then the fish live off of the invertebrates, and on up the chain it goes. So this is our classification for looking at plants and how to identify them just by their overall growth ecology. There's a number of ways to control plants. These are the basic ones here: mechanical, which involves mowing, pulling, cutting, that sort of thing. We have some physical methods such as winter drawdowns to try to subject shallow shoreline areas to freezing temperatures, which will at least temporarily kill some plants. Digging ponds deeper, such as around the shoreline, as I mentioned earlier, to help prevent the establishment of unwanted vegetation. Fertilization, and some other types of controls. I would put aquatic dyes in this type of physical control, because you're basically trying to shade out the growth from the bottom of the pond. We'll talk about that a little bit later. Biological control really is limited to triploid grass carp for soft stem vascular plants and branched algae. Think of these as easily digested plants, and I'll show you some examples of those later on. They're not going to eat really tough, hard to digest plants such as cattails, lily pads, and things like this. It's just too hard to digest, but they will eat easily digested soft stem plants and branched algae. And last and finally not least are herbicides, algicides, which come in liquid and granular formulations. So we'll discuss all these to some extent and go through some of the more common plants that people see in their ponds, and hopefully it will serve as somewhat of a guideline for you to start looking at your situations. Mechanical removal will work if the plant population or algae population has just started. You might be able to do some raking and pulling of small amounts of plants. Obviously, if it really gets to be a big job, it's not practical. So that is a control method in a very small pond situation, or where growth is just starting, such as cattails getting established on a new pond. There's a small window in there in which you can pull cattails out of the mud without a lot of trouble. But if they're there for any length of time, they start developing an extensive tuber system, and they become very difficult to remove, almost impossible without digging them up either by machine or shovel or something. Physical controls, pond drawdowns only really work in ponds that have drains. Most of our ponds don't have drains, so I'm going to kind of skip over that one. But aquatic dyes, we see quite a bit, and also aeration. And aeration will just disturb the water. A lot of plants and algae really like that quiet water situation where the sun's beating down through the water, and the water's warm and there's plenty of nutrients. By keeping the water moving, it helps control or marginalize a lot of plant and algae problems. So although it does not solve aquatic plant growth issues, it helps to control the overall problem. Dyes, many of you have seen these things. They come in all kinds of different shades and colors, liquids, powders. Usually your farm supply stores of one sort or another will carry these. Most of the ones I'm familiar with are just inert chemicals, food coloring. Aquashade has probably been around as long or longer than any of them. In this particular one, you use about a gallon in a 1 acre pond, about 1 gallon per surface acre. It won't work very well in real shallow areas like 2 foot, 1 foot of water, but it will work in the deeper areas. And the idea is that it tries to shade out, it causes a coloration to the water. It shades out sunlight from hitting the bottom of the pond and allowing growth, plant growth, algae growth to grow from the bottom of the pond up. So that's really how it's supposed to work. The problem with this particular type of control method is if you have a lot of water moving through the pond, your dye is not going to stay in the pond very long. Now, that having been said, I've seen it last for months in ponds where there was little or no water exchange. So it will last a long time if it has the retention time, if it stays in the pond long enough. So you can try this. It's questionable as how well it works, but some people like the looks of it, and it won't do any harm. It just depends kind of on the situation if it really does much plant or algae control. Biological control, again, really all we have to deal with are triploid grass carp. These fish have an extra chromosome, which makes them sterile and unable to reproduce. They're fairly expensive, somewhere from $10 to $15 a piece. You want fish that are 10 inches long or longer if you have largemouth bass present in the pond, because bass love to eat these fish. And you want ones that are big enough that'll make it difficult or impossible for bass to eat these fish. How many to stock? It's kind of an art. I don't stock 50 fish per acre, but in some cases, maybe a dozen or 2 dozen per acre in a real bad infestation situation. They grow quickly. These fish are going to be good for 2 or 3 years, and then they get kind of old and fat and lazy, and the grass carp get up to 20, 30 pounds quite easily in ponds. And they're very powerful fish. So if you try to get rid of them in any way, be careful handling them. They're super strong fish. But yeah, basically in your stocking scenario, you're looking at anywhere from a few fish on to an acre on up to maybe 15 or 20 per acre. I don't stock generally beyond that. If the aquatic plant problem is that bad, typically we do an integrated pest management approach and go in and knock it back with herbicides first, and then come in with grass carp to try to maintain the plant control after we've done an initial knockdown with herbicides. Although the carp are not cheap, they can be less expensive to stock than would be repeated repeated herbicide treatments. So that's something to consider. So it's a tool. It is not a silver bullet, but we have been using them with some degree of success in some situations. Chemical control, again, algicides and herbicides. These are typically in a granular or liquid formulation. And as often as not, we at least try to gain some initial control with these and possibly look at the other control methods moving forward. Somewhere in this, I have a aquatic management herbicide sheet. We'll get you copies of this if you want one. I've got one here in front of me. This lists the herbicides and what plants they control, and it's a pretty useful tool. In the Extension Service, we've got a lot of publications on pond management and on plant control. We've got website applications. We've got a number of things that can help pond owners first identify their problem and then as to what to do about it in their particular situation. So this one has been around for a long time. It could use some updating, but it's still a pretty good fact sheet. We can get you a copy of this if you want one. The first thing you need to do after you've identified your plant correctly, and you can help by April or myself can help with this. If you send us digital images, we can try and make sure that your plant is identified correctly. The second thing you have to do is assess your abilities. Do you have the equipment to do this and do this safely? Obviously, you have to follow the protective equipment recommendations on the label. Those are laws, so you want to follow the label and the laws on the label. And to do this safely for both the environment and for yourself. So if you have too big a body of water, it might be better off to consider calling a professional applicator service to treat these things, these ponds, because the bigger bodies of water, the bigger the body of the water, the harder it can be to treat. So again, following the label is the law, and make sure we have the right herbicide, algicide for the offending plant at hand, and then following the label in an effort to try to control. Algae control. Algae control is important. We have probably most of our calls, half of our calls at least, are on algae and algae related issues. But algae gets kind of a bad rap. It's estimated that 50% of the Earth's oxygen is actually generated from algae in the oceans, lakes, and other bodies of water. So we need algae. We have to learn how to live with it, and we have to learn how to manage it. Algae is going to be in just about everything you have. It transfers by spores. If you leave a glass of water on a table outside in the summertime for about a week, you're going to see it turn green. And that's because algae spores have gotten in there and started growing. Probably the most frequent offender we have is filamentous algae. And this is the hairy stuff that starts growing on the bottom of the pond and comes up to the surface and forms these mats. You can see these mats here. Eventually they'll break away and start floating around on the pond in this form of almost raft-like mats. This is kind of hairy stuff. It's not pleasant to swim in. It tangles up your hooks. It's even hard to get a boat through areas like this. But you see this shallow portion of this pond, that water might be a foot or two deep. And this is exactly the kind of habitat algae and aquatic plants like, because the sun can shine all the way through to the bottom of the pond. And then this stuff starts coming up from the bottom in the shallow areas of that pond. And there's a number of different kinds of chemicals we can use. The most common is copper sulfate, which has been around probably since the 1950s. Again, it's fairly inexpensive with regard to the price of other aquatic herbicides and algicides. So we'll talk about that one a little bit. It's fairly easy to use, and you can buy it in most farm supply stores in your counties. There are other things we can use. They tend to be more expensive, and sometimes it's best almost to try copper sulfate first, see if that works. Some of these others can be tank mixed with copper sulfate, like diquat. Some of these others, like the peroxide based algicides, which we'll talk a little bit about later, can't be mixed. So again, reading the label will save you a lot of trouble. So the way I recommend we treat with copper sulfate is generally diluting the crystals in warm water if possible, but diluting the crystals in clean sprayer water, and then spraying it out not only on top of the growth, but in and around the sides of it. Try to get as much of that chemical, as much of that plant exposed to the chemical as possible, and this will get you the best control. You don't want to get this stuff on bare skin. It's caustic and it can burn your clothes and other things. So you want to make sure that you wear protective equipment when you use this. Common sense stuff. Don't spray in windy conditions and this, that, and the other. Stick the wand down in the water, and this will create a plume, I should say, of bluish green water, and you'll see actually where the chemical is in the water. So you'll be able to track how well it's getting to the algae. It's a very common algicide. It's been around for years and years. I don't generally recommend whole pond treatments because we can lead into problems of too much algae dying at once and depleting the oxygen and killing fish. Also, it may be a good idea if you're going to do a whole pond treatment, which again, I'm kind of leery to recommend, to have the alkalinity of your water checked. If the alkalinity, the buffering capacity of the water is too low, this can actually be toxic and kill fish just outright, just chemical toxicity, not from killing the plants and depleting the oxygen, but just copper toxicity itself. The biggest mistake I see with copper sulfate treatments are people just broadcasting the crystals out. Unless they are very fine, almost a dust, these crystals will sink into the pond muds and they won't do much good in terms of controlling your algae problem. Diquat is another algicide we can use. It can be tank mixed with copper sulfate. This is a non-selective algicide and herbicide, can be used in many aquatic applications. I do recommend it a fair amount. This, like copper sulfate, is a contact herbicide. It is only going to kill what it comes in contact with. It doesn't have systemic properties. The one thing about using this particular chemical is you don't want to stir up the pond muds in the shallow areas when you're treating it. The chemical will bind very quickly with the negative particles, the negative mud particles in the water, and basically render the chemical useless. It will just bind up and not give you any efficacy in terms of controlling your algae. So be careful of that. Don't stir up the mud, or stir it up as little as possible. Also, this is another good one for partial treatments. It kills algae and plants very quickly. And if you kill too much of this plant biomass, the algae, or rooted plants for that matter, at one time, it can deplete the oxygen and cause you a fish kill. Specifically during the summer months when the water is warm. There are chelated coppers out here. This stuff is supposed to be more effective, longer lasting, and less harmful to fish. It is also more expensive. So keep that in mind. If you have a small pond or application, it might not matter so much, but if you've got a lot of water to treat, a lot of algae to treat, let's say, just going with the regular copper sulfate might be less expensive. This is also supposed to control some types of algae that regular copper sulfate won't control. But for those, I usually recommend a tank mix of both diquat and copper sulfate to get the really aggressive, tough algae like Pathophora that we see in late summer. On to blue-green algae. These are planktonic algae that float around, kind of create this blue soup color, or not blue, but blue-green soup color. I see a lot of it kind of in the form of what I would call a Kelly green type floating scum, as you see on the lower picture in the lower image in this slide. And this stuff is a real nuisance. It comes on typically midsummer into early fall. It can last for weeks. In some cases, it can smell bad, and in some cases, it can be toxic. So it's not anything to play with. The testing of this stuff is kind of, it's just not in a real good state right now. It has to be lab tested. A lot of times, by the time you get the feedback from the lab, after spending hundreds of dollars, it's a week later. So it's yesterday's news by the time you get it. But you generally see this type of stuff, and again, in quiet waters, it can be a bluish green color or a real green, Kelly green color like what you see here. So be on the lookout for this stuff. And if you see this in your pond, it's best to keep animals, children, that sort of thing out of it, just to avoid any potential toxic situation. What we really prefer to see is green algae up on the top picture, which is a kind of a deep ivy green, versus the blue-green. I don't think that picture down there really does it justice. This blue-green color, which is more of an iridescent green color. So green algae is really what we'd like to see. in our ponds and not so much the blue green. Unfortunately, in our hot summers and our little stagnant ponds, we tend to see blue green algae in late summer, at least, and early fall. They all require a lot of nutrients, water, and basically warm water at that. You will have algae throughout the winter months, but they're different kinds, different species, and generally they're not problematic. Here's just a few pictures of various blue-green algae I've taken shots of over time. Some potentially toxic algae, such as these, anabenas, microcystins. This particular chemical was used to control specifically blue-green algae, better called cyanobacteria. Really, it's not really an algae; it's a bacteria. And these are peroxide. This is one of the peroxide-based algicides, and this will be pretty effective, really, on these blue greens. And this was developed for reservoirs, municipal drinking waters, and this sort of thing. So you can try to control this stuff with both copper sulfate and these peroxide-based herbicides, or algicides, I should say, such as Green Clean. And there's a number of them on the market now. This is off patent. Phycomycin's one. There's a number of them that are available. These will not harm plants. This is just strictly algae control. Anything any plant that this comes in contact with, it really won't hurt in any meaningful way. So this is a product that's out there. It's more expensive than copper sulfate, but it doesn't have some of the environmental impacts that copper sulfate does. So moving on to shoreline and emergent vegetation, a lot of people call about this stuff as well. And you can see where you have in this picture cattails, and there's willows in the foreground and rushes and all kinds of stuff. Just like a garden in your yard, you don't really want to let this stuff get out of hand, so where it's minimizing your access to the pond. You want to be a control freak, and if you see too much of this stuff coming up, spray it, mow it, do it what you have to do to keep it under control. A few patches of cattails are nice to look at and good for wildlife, but eventually this type of growth will surround the pond perimeter, and it will keep you out of your pond. So you really don't want heavy growth getting established and then having to go in and try to control it. It's best to do it kind of piecemeal, like I said, like weeding a garden. Go out there every few weeks or couple weeks, whatever it takes, to try to keep these things in control. You're not going to eradicate these plants. They're too successful. They'll spread from one pond to another by wind or waterfowl. But you can at least control the situation on your property by being attentive and going out there and treating on an as needed basis. Cattails, rushes, sedges, these types of plants, these tough vascular plants, I try spraying with glyphosate. Again, an aquatic glyphosate is available at most farm supply stores. You'll want to use a non-ionic surfactant, which is basically formulated for aquatic environments, which is safer to use. There are other options in terms of translocated herbicide in addition to glyphosate. Often these are more expensive, so you can try glyphosate in many of these cases. And when you want to apply this is actually when the plant is growing in the early summer stages and the plant is sending out new growth, and this will take the chemical down from the plant leaves into the root systems, and you'll get better control than you would if you started planting spraying the plants when they are more dormant later in the year. So yeah, and it's probably going to, in a situation like you see in this picture, it's probably going to take multiple treatments where there's such dense growth. The idea is not to let it get so dense so that it's harder to treat later on. Here's cattails releasing seeds. You've seen these things. Red-winged blackbirds like them. These wind-blown seeds will go from one pond to the next. The cattails will also spread very nicely, very via a tuber system underneath the pond mud there. Pond mud's in the bottom, and they'll kind of pop up. Almost looks like a string of Christmas lights under there. You'll go a foot or so, and there'll be another plant popped up along this runner, and then another one and another one, and that's what makes these things such a monster to get out of the pond bottom when you try to mechanically remove them. So again, best to get these plants when they're young. You can have a few pockets of them here and there, but you're going to have to manage them and keep them from spreading throughout the edge of the pond if you want to access that pond over time. Willows, same way. As soon as you build a new pond, it's not long, and black willows, cattails, and some of these other plants will move in. They'll come in by waterfowl, windbows, seeds. I'm not sure all the mechanisms they get there. You can see in the background of this picture some little stand of cattails in the distance, and that's fine. But limit some of this growth, mowing, spraying, whatever it is you got to do to make sure that these willow trees don't get established all around your ponds. While we're talking about trees, we certainly want to make sure we keep it off the earthworks, keep woody vegetation, shrubs, trees, all this off the dam, because they can cause problems later on when the roots, if the tree were to die, the roots decay, water can travel along that cavity and compromise the structure of the dam, weaken it, and possibly cause a blowout. So you can have trees and all this stuff along the banks of the pond just fine, but keep woody vegetation off the dams. And by that, you might have to mow it at least once a year, maybe twice, but that should suffice in keeping big woody shrubs and trees off the dam. Glyphosate are known as all kinds of stuff now. This is the aquatic equivalent of Roundup, all kinds of different names: AquaPro, Aquaneat, Aquamaster, Catplex, on and on it goes. You can buy this stuff usually locally. The aquatic glyphosate costs more, but what's important also is to make sure that you have an aquatic surfactant mixed in or to mix with it. This will not be injurious to aquatic life. This particular, once a glyphosate hits the water, it's completely it's done. It has no efficacy in killing anything once it comes in contact with water. So if you get a little bit in your pond and you're using the right surfactant, it's not going to kill. It shouldn't kill fish, invertebrates, this sort of thing. So that's one thing to know. Once it comes in contact with water, the chemical will no longer work. Here's just an example of a non-ionic surfactant. There's a bunch of these out here. Some of them are citrus-based. These are used as stickers, other penetrants, other things like this. These aquatic plants have kind of a waxy cuticle on many of them, and it's hard for the chemical to penetrate. So the surfactant is important in getting an effective penetration, residence time, if you will, on the leaves of the plant, so that it can actually control the plant. So don't negate the use of a surfactant, and it'll usually be right there on the label telling you how much to mix in and this sort of stuff. This is just a glyphosate treatment we did on some spike rush, and you can see a little bit of water primrose in the background. Again, this is a translocated systemic herbicide, so it will make its way down into the root structure and actually kill the plants that it comes in contact with. The whole plant is the not just the portion of the plant that the chemical comes in contact with. Some of our other more tough plants to control are water lilies and water shield. These are very difficult plants to control. Again, you can almost see that waxy sheen on these leaves. Typically, I'll go after these with 2,4-D granular. You can try glyphosate, but a lot of times there's not enough of the plant above the water level to get a very good contact on it. So I'm not a huge fan of glyphosate. glyphosate when trying to treat these particular plants. 2,4-D will get in through the root system. Fluoridone works very well. We'll talk about that a little later. But these are tough plants to control. So I would recommend people not to plant lilies because they can get out of hand. They drop, both of these plants will drop resistant seeds, which can live for decades in the muds and then germinate. So once you have them, once you have a seed bank in the bottom of that pond, you're looking at fairly frequent treatments to try to exhaust that seed bank. So everybody loves these little white flowers, but these, you know what happens after these flowers are gone? They start dropping seeds, and that's where your problems begin with water lily containment or management. We're not even talking about elimination here. We're talking about just trying to manage these things. For some of our small ponds, I know particularly in eastern Kentucky, these plants will just take the whole pond eventually and cause quite a management problem for pond owners. Navigate, this is another one of the 2,4-D products, has been around for years and years. There are a number of 2,4-Ds that are used or labeled for aquatic use. I'd recommend getting those. There's dozens and dozens of 2,4-D products on the market. And make sure you get one that's suited for aquatic use. First of all, it's the legal thing to do. And secondly, it will be less injurious to your pond environment. And 2,4-D is pretty tough stuff, so you really don't want to. You don't want to play with it. Follow the label and the recommendations, and you should get pretty good over time. Might take multiple treatments, but you should be able to get good control over time. And this again is another systemic herbicide. This is a little demonstration I did years ago with a grower, a farm owner. You can see this is a plant. This is parrot feather. This is an exotic plant that really shouldn't be in the country, even on the left. You can see that green shoreline, and about a week later, there's a burn down after a 2,4-D treatment on the right. So stuff does work if applied properly to the right plant in the right situation. Submerged and floating plants. These are your pond weeds, and it's an unfortunate name, but these are little nondescript plants, and they are in fact called pond weeds. I don't know why, but we see quite a few of them. Great duck forage. There's a few dozen. Well, there's probably a few species we see quite frequently in our ponds. This is the type of plant material, this soft sort of leafy plant material that grass carp will eat. We can come in here and do a contact herbicide control at diquat, and we can do some other more systemic type controls with other plants. But you'll see pond weeds around quite a bit. This is American pondweed. I don't know if you can see the little seed head on that bottom picture sticking up, but this is very good duck forage. And duck hunters and waterfowl enthusiasts actually go around planting this kind of stuff to entice ducks to come and feed in their duck hunting ponds. But you can see this stuff, and it too will get into these thick growth patterns and interfere with boating and fishing and swimming and that sort of thing. Variable leaf pondweed I see out here quite a bit. Not quite as dense as some of these others, but it too can be a nuisance. Again, just some limited growth of this type of plant is helpful in a pond. It's just you don't want it growing so much to whereas you can't really interact or use your pond the way you want to. So little is good, too much is a nuisance. Curly leaf pondweed, you'll see this in various places in Kentucky. This is an exotic that's come over from Asia. This plant actually grows in the wintertime, and it can be a real nuisance in the Midwest, upper Midwest, and a difficult plant to deal with. So just another one of our pond weeds. Fortunately, I don't see a ton of this, but I do see it sometimes. Another plant, naiad, similar to pondweed, only whereas pondweed has alternating leaves on the stem. Naiads have opposite leaves. Again, another little indescript plant. These types of pictures, these good quality pictures, are really critical for us to try to identify this stuff, get the right herbicide, or determine whether or not grass carp can eat this stuff. So good pictures are really worth the work it takes to get them for identification purposes. And if we have good pictures like this, 90% of the plants and algae problems we have, we can pretty much identify either by text, email, or something like that. Here's another naiad right here, and you can see it floating in this white dish, a pan, even a white 5-gallon bucket with a little bit of water in it. Really helps us, teasing out a strand or two, really helps us identify these plants. It's an easy deal once you do this. If you have a big ball of plant material that's on the tailgate of a truck, or somebody holding it up in the air, that's not very helpful in terms of identification. Something like this really goes a long way in helping us trying to figure out what this type of plant is. More complicated picture here, a number of things in here, but coontail is those whorls right there on the right. You can see it best. Whorls of leaflets, kind of looking like a raccoon tail, at least according to some. Reward, weed treen, all these diquat products will all work on these types of plants. Again, they're contact herbicides. A non-ionic surfactant is used to mix in with the plant, and it can get this stuff under control quickly. Cara, this is actually a branched algae. It looks like a rooted or a vascular plant, but this is actually an algae. And copper sulfate will work on this. Grass carp will eat this stuff. Again, it's a fairly soft stemmed plant, easy to digest. Looks similar to coontail, but Cara is different, and it's actually an algae. So there is some confusion. The better pictures you have of the plant, the easier it is for us to identify them. Some of the other herbicides we have out there, Aquathol is one I use sparingly, but we do use it. It has both actually contact and systemic properties for it. And this is only for vascular plants. It's fairly expensive, but it can be effective, and it's liquid and granular formulation. It'll control, well, these vascular plants that we see up here, particularly used with pond weeds. Duckweeds are a real problematic plant, and we get them, they're floating. They have these little tiny leaves, and if you look at it, there's probably 1/4-inch long roots hanging down from them. These things take take nutrients directly out of the water column as they float on the surface, and they reproduce very quickly, particularly during the warm summer months. So the best thing to do, if you can do it, is try to minimize the nutrient load going into that body of water. If you can make some sort of changes to your landscape, the nutrient loading going into the pond, it will benefit quite a bit. The best way to control both duckweeds and watermeal, which I'll talk about in a minute, is basically to starve them out. Once you have them, as long as that source of nutrient is there, they'll use it up, and they'll present problems. There's a number of different herbicides you can get out there to treat this particular plant. Duckweed diquat will work. In the old days, they used 2,4-D liquid. I'm not a huge fan of that. But there are, diquat works fairly well. Fluoridone is another herbicide. It's a slow-acting systemic herbicide, which is very effective, but you've got to get the retention time in the pond. You've got to get 30 days retention time of the chemical in the water for it to be effective. Watermeal, although it's the smallest vascular plant we have, and you can see it mixed in with little blades of duckweed here, although it's the smallest plant we have, it's probably the hardest to control. There are a few herbicides we can use. Fluoridone is one of them, probably the one I'd recommend most, but I would use that in late summer, early fall, when our water retention times are better. This time of year, we'll get hard rains, and 2-3 inches of hard rain will wash your chemical out of your pond, and you don't want to do that because this stuff is very expensive. And again, this is probably the hardest plant we have to control, and it's really dependent on dense nutrients out there. So if you can minimize nutrient loading, the nutrient content of your water, you're that much better off in trying to control this stuff. The bad news about fluoridone, sold under the name of Sonar, Avast, I believe Whitecap is another. It controls controls a lot of different plants. Let's say that. It's very good on watermeal and duckweeds. The problem is it's slow acting. It takes 30 to 90 days to kill plants. And that means it has to be in the pond for at least 30 days for you to gain some efficacy in trying to control these plants. And as you see on the bottom, it's very expensive. Can be close to $2,000 a gallon, both in liquid and in granular form. So that discourages a lot of people from using it. It is a good herbicide, but it is also very pricey. So duckweeds and particularly watermeal is probably the hardest. I would say watermeal and water lilies are probably the hardest plants we come across when it comes to control. Flumioxazin is actually a contact herbicide that can be used for watermeal and for duckweeds, but you've got to get out very early in the morning and use it. It's still fairly expensive, and it will take a lot of plant growth down in a hurry. It's a good herbicide to alternate with fluoridone treatments. The problem is that the plants can become resistant to it very quickly, so you don't want to use this stuff repeatedly. But Clipper, relatively new herbicide, can be used to control watermeal and duckweeds. And this picture is pretty common. You'll see the two in together a lot of times. You'll see the bigger blades of duckweed in there, the little granules of watermeal. And the watermeal will feel like cornmeal or sesame seeds between your fingers. It is supposed to be the smallest vascular plant in the world, but it's tough stuff to get rid of, I can tell you that. So, this is a brief run through of this stuff. Here's some websites that have various information. Some of these will help you identify plants, as the top two will. We also have all kinds of aquatic plant fact sheets. Don't go it alone. If you have questions, you have plants in your pond, you don't know what they are, send us digital pictures. We'll try to figure it out and get you help. You can go to local farm supply stores. Sometimes they know, sometimes they don't. But if you find yourself in need of trying to identify your plant and what to use, give us a call or send us some digital pictures via your phone or computer, and we can try to get you on the right track. That's about what I had. We've got a few minutes, try to answer any questions people might have. Usually this stuff, aquatic plant control, generates plenty of questions, and it's my website on this slide here if anybody has looking for any further information.
All right, we have one question from David. If filamentous, thank you, algae. I had that in my brain, so I looked at it and I was like, wait a second, it's not coming out of my mouth. It is an annual problem. Can you treat the pond edges preventatively before the algae gets started?
Yeah, that's a great question. And there are no real pre-emergence for this particular, since it's a spore-driven algae populations are short-lived, maybe a few weeks at most. So it's not like a rooted plant. The spores keep popping up. So unfortunately with algae, it's a pretty continuous battle to control algae in ponds. And the interesting thing is there's different species of algae. that will grow during the winter time, cold water forms of algae. Just most of us are not interacting with our pond environments in the winter time, so we don't really pay attention to those. And the warm weather ones get the get all the attention. But unfortunately, there is no real long-term treatment for algae. It just the populations turn over quickly, and it's just kind of an ongoing situation.
All right, next question. What is best to use on willows, glyphosate or Habitat?
I would probably start out with glyphosate, get the trees when they're small, when they're just popping up along the banks. Habitat's more aggressive. You can use that. Some of these plants, you just want to make sure, that you don't spray the wrong plants or other plants, because you can kill them as well. But I'd probably start out with glyphosate and see if I couldn't get some control with that.
Okay, I have a couple questions here with the folks in my office. First one is,
if you're using any glyphosate, is it recommended that you use an aquatic substance with something that actually can make the water?
could you hear
April,
that?
that kind of broke up pretty bad. Can you repeat it?
I get a megaphone.
Yeah, you want to come up here?
Use any kind of glyphosate. I'll use the example like cornerstone. Can you use an aquatic substance so that it will not contaminate the water as bad?
I'm not sure I'm getting all the question here. The aquatic surfactant is safe to use in an aquatic environment, if that's what you mean.
I think he's asking about glyphosate, the different types of those, if it's
Well, cornerstone is the one
like Cornerstone.
Yeah.
Yeah, I don't know about that particular one. I know like TSC will have them labeled for aquatic use and that sort of thing in with their pond management top stuff, in with the dyes and that sort of thing. So you probably need to look at the label. There are hundreds of different of glyphosates out there, I believe, and the aquatic registered ones will generally say so and be in kind of a different section. And unhappily, they will be more expensive. A whole lot less aquatic herbicide is sold versus that than what's used on land. So I don't know if I've answered your question, but that's typically the recommendation we give. And most of this stuff, not all of it, is mixed in with a surfactant.
All right, he said that you did answer his question. So the next question is,
Can we use like a swimming pool test kit or test strips to test the pH and the alkalinity of our pond water?
You can, yeah. Sometimes they're not real accurate. They're just calibrated different. I have used those. You can bring it to a place that does sells spas and swimming pools and that kind of stuff, and hot tubs, whatever. And a lot of times they'll do some water testing for you. Some of those, depending on the kit, the test kits are pretty good, and then others aren't. So it really just depends on what your test kit, the kit you buy. Swimming pool pH tests typically are a pretty narrow range, maybe somewhere from, I don't know, 6.5 to 8 or something like that. Whereas for pond testing, what I use, I have one that goes from a pH of 4 to 10. So it's just a lot different in terms of in how it's calibrated. But some of the test kits are good. Some of them maybe not so much.
okay, the next question is it okay to add a colored blue tint to the pond? Is it harmful to the fish?
No. In fact, the one I showed you, Aquashade, and some of these other ones may not be, but that's even cleared by FDA for livestock and that sort of stuff. This stuff is pretty much inert food coloring, so it's really not going to have much effect on anything because it really doesn't have any chemical properties. Probably the most annoying thing about it is if you get it on your hands, it'll turn your hands blue or green. So beware of that. I'm told by applicators that shaving cream takes that off of your hands should you spill the stuff. And invariably you do when you get messing with the dyes, particularly the liquid ones.
All right, last call for any questions. Samantha, Philip, do you all have any? I don't see any more in the chat.
About the cattails.
Hold on real quick.
Okay,
Talk and see if they can hear you.
Okay, if you're trying to reclaim a small pond that's already infested with the cattails, would you go in and spray first or just go in and dig them out, burn them off? Where would you start at?
You know, if it's really just filled up with cattails, sometimes folks will get in there with like a bobcat or something like that, a skid loader and push and just, you know, scoop them out. And then go in, you know, if you've got a lot of that straw colored vegetation out there, spraying that's not going to do any good anyway. So I've seen ponds just completely, especially small ponds, being taken over by cattails. At that point, you might want to consider some mechanical removal. I've seen, you know, skid loaders and that kind of stuff get through fairly, you know, a couple feet of water even to scoop this stuff out. And that might be a faster, simpler way to do this, but it really depends on how bad the infestation is as to how you go about it. Chemically can be pretty slow and tedious if you've got just a pond choked with cattails.
You wouldn't want to spray them first to try to kill the root system in the water before you dig them to be more effective. It means you're going to have to dig them anyway.
Yeah, you know, I guess you could. The idea of spraying is trying to get it to that point where it doesn't take over an entire pond. Once it has taken over an entire pond, you might want to get a little more heavy-handed. You get heavy equipment in there, they'll come out. It's just you really can't do it by hand very well. You break off the fronds or the leaves, and the root system is still down in there, and it just regenerates more plants, more shoots, if you will.
Would it be a good idea if you scooped it out of there and once you got it all cleaned out, there's still tubulars in the bottom, but could he spray them to kill?
Yeah, afterwards, if I went in there, I mean, invariably you're probably going to miss some of the roots and tubers in there, and there'll probably be some growth coming up. And at that point, after you've gotten rid of most of the plant mass, you know, if there's some stragglers left behind, I would consider spraying that. It just, at some point, you know, the horse is kind of out of the barn when it comes to chemical control. When you get these ponds that are just completely choked with plants like that, you can't even really get to them to spray them very well.
Is there a good answer? As far as I have a new pond I've had in 2 years.
Mhm.
Looks good, looks stocked with fish, and I haven't fished it yet, but is there anything, I don't have much plant life in there now.
Mhm.
But I'd like to get some of the whatever kind of fish were there. All right, carp,
No grass carp?
I'd put a couple of them in there. And I'm wondering, is there any good algae or plant I can put in there that's not too aggressive to feed them or the other fish?
Not really. Usually that stuff will volunteer. You have a pond long enough and that stuff, you know, you build it and they will come. Honestly, if you've got a few carp in there and they're not getting too big and too lazy, to keep them a little hungry in there might be beneficial in terms of controlling any problems you might have up the road. But yeah, pretty soon, a year or two after you build a pond, stuff will start moving in there, you know, either from waterfowl eating seeds and, you know, dropping them in your pond or windblown seeds and stuff. It's generally doesn't take too long. And you will start seeing that type of growth. Probably the best thing you can do for new ponds is have the water tested and see if it needs ag limestone or not. And that can help with fish production in particular.
Okay. Yeah, I plan on getting some limestone put in there.
Right.
I've already had, it's blue. I had several species 2 years ago or 18 months ago, I stocked it. So all those, I didn't have no fish dying. So I assume they would float to the top if they died.
Right.
Everything looks like it's still alive in there.
Well, good. How's the fishing? That's the big question.
I haven't started fishing yet.
Okay.
I'm gonna start soon.
Okay, yeah, see how that looks this spring. I mean, 18 months. You ought to have some bass, half decent size, not huge, but half decent size. And you ought to have bluegill, good to go in terms of fishing.
Well, the bass I put in there, I bought, I think 10, and they were only like 2 inch, 3 inch. They were small. But the
Right.
bluegills, hybrid bluegills, regular bluegills, channel cats, red ear sunfish and some other species. I have in there now.
Well, get out there and fish and see how it's doing. If it's
I'll
good
do that.
fishing, if it's good fishing, we will fix it.
All right, thank you.
You're welcome.
Any other questions, Philip, Samantha? All right, well, if you all think of any questions after you leave here this evening, just reach out to your local extension agent. We'll reach out to Forrest and bend his ear and get answers to everything. So again, thank you all so much for joining this evening. I will run a report from who attended tonight and how long they were on and send it to the agents in our surrounding counties for CAPE education, just so they can look to make sure you were on and stuff. So anyways, other than that, thank you, Forrest, again. We greatly
Thank you,
appreciate
April.
so very much beyond
Thank
what you
you.
can
And
imagine.
thank you all for joining us tonight, and let us know if you have any questions.
All right, thank you all so much. Safe travels home. Good evening.